Take 3 and hopefully the final take. Let's first go over the worksheet from yesterday. So yesterday's worksheet, you guys did okay on the first two, knowing to break up the square root of 45 to 9 times 5, 9 being the perfect square. Square root of 9 is 3. Bring down the square root of 5, so it's positive negative 3 square root of 5. This symbol is called a radical, so sometimes I'm going to say positive negative 3 radical 5 instead of 3 square root of 5. Just realize that that's the same thing. Here, square root of both sides. Do not forget the positive negative in front. 50 is 25 times 2. 25 being the perfect square. Square root of 25 is 5. So the final answer is positive negative 5 square root of 2. Okay, those of you who are unsure about the perfect squares, make sure you look it up, and you need to know your perfect squares for this entire topic as far as next year and the year after that as well too. Okay, number 3. Here, some of you had issues dividing by 3. 60 divided by 3 is 20, not 30. Maybe the one in the lesson was 30 because a lot of you made that same mistake putting 60 divided by 3 is 30 instead of 20. Okay, now you take the positive negative square root of 20. 20 is 4 times 5. Square root of 4 is 2. So positive negative 2 square root of 5 is your final answer. Number 4 had the most mistakes. First, people didn't add 8, they subtracted 8 in some cases. Again, maybe because you were following along with the lesson. So to undo minus 8, you have to add 8. You get x squared equals 72. When you take the square root of both sides, you get x equals the positive negative square root of 72. 72 is 36 times 2. 36 is the biggest square, perfect square that'll go into 72. So if you use 36 times 2, you get the final answer, positive negative 6 square root of 2 in one step. Let's explore a couple of the ways that you guys did it. Those of you who left your answer 2 square root of 18, I circled the square root of 18 because you got that 72 is 4 times 18, which is true. Except 4 isn't the biggest perfect square because 36 is. And what that leads to is now the square root of 18 could be further broken down into 9 times 2, which is 3 square root of 2, which would give you the same answer. So that's why I always say get the biggest perfect square so that you can get it in one step rather than 2. And again, another common error here is getting that 72 is 9 times 8, which is true. And 9 is a perfect square. But if you put 3 square root of 8, I circled square root of 8 because square root of 8 has a perfect square that goes into it, 4. So you would have to further break it down to 4 times 2. Square root of 4 is 2. And again, you would end up with the same answer. So that's why I didn't mark it wrong. I just circled the square root of 8, or I circled the square root of 18, because those square roots could still be broken down, meaning it's not in simplest radical form. The only way it's in simplest radical form is when the number under the square root cannot be divided by a perfect square, so it can't be broken down more. So your answers in this homework assignment all had square root of 2 or square root of 5 that cannot be broken down more. Moving on, even though Blake interrupted because I'm not going for a take 4. Okay. So again, we're spending another day on using square root method to solve these quadratic equations, except in the last lesson, we learned to isolate the square term to solve using the square root method. But the square term doesn't have to be just x. And yesterday, when we isolated the square term, it was just x squared. Today, the problems are going to look like this, where what's being squared is a binomial, like here, x minus 2, x minus 3. So when we're taking the square root, we're taking the square root of the binomial squared, which undoes the square. Okay, the square root of the binomial squared, we're going to end up with just the x plus 2. The squared goes away. The right-hand side is going to be the same. We have to remember positive, negative, square root of 12, the side with the number. Except now x isn't isolated when we take the square root of both sides. We have this plus 2 that we have to subtract from both sides. So we get that x is equal. Now what are we going to do? We have this positive and negative square root of 12 that we have to subtract 2 from. So what we always do is we put that -2 or whatever number we're doing on both sides in front of the plus minus square root of 12. What that means, but we won't write out, is it could either be -2 plus the square root of 12 or -2 minus the square root of 12. However, instead of writing those two separate solutions, it's okay to just write it like this, -2 plus or minus the square root of 12. So I'm going to erase that. I just wanted you guys to see that that's what it meant. However, like always, the directions say simplest radical form. And the square root of 12 can be broken down because 12 has a perfect square that goes into it. What perfect square goes into 12? 4. And it's 4 times 3. We take the square root of 4 is 2. Bring down the square root of 3. So I'm going to bring down the answer. X equals -2 plus or minus 2 square root of 3. Again, we could write this two ways, -2 plus 2 square root of 3 or -2 minus 2 square root of 3. However, it's better, easier, more efficient to just write it once. Next one is exactly the same, so you should follow this when you're doing the worksheet. Because we have the binomial base, x minus 3 squared, it's already isolated. So I take the square root on both sides. On the left-hand side, we are ending with x minus 3. On the right-hand side, positive negative square root of 80. Now what are we going to do to get x by itself? We have to add 3 on both sides. And again, where is the 3 going to go? In front of the positive negative square root of 80. Lastly, I'm going to simplify that square root of 80. What perfect square goes into 80? You're probably going to want to put 80 divided by x into your calculator. Look at the table of values, and you'll see that 5 times 16 is 80, and 16 is your perfect square. So 4 square root of 5. So I'm going to bring down x equals 3 plus or minus 4 square root of 5. Final answer. I would never write it twice, 3 plus 4 radical 5 or 3 minus 4 radical 5. Just write it once. Okay, do you notice what's different about number 3? Number 3 has a binomial squared again. However, it's not by itself. There's that 2 in front. So what are we going to need to do first, boys and girls? Divide both sides by 2. Now I'm going to have that binomial squared by itself, and on the right-hand side, 54 divided by 2 gives me 27. Now, everything after this is exactly like number 1 and 2. Take the square root of both sides. I get x plus 1 on the left-hand side, positive negative square root of 27. Then, I'm going to isolate the x by minusing 1 on both sides. I get x equals, the negative 1 again goes in front of the plus minus square root of 27. And then lastly, I need to get simplest radical form. Square root of 27 is 9 times 3, both under the square root. The perfect square 9 gets me 3. So x equals -1 plus or minus 3 square root of 3. Final answer. The next one's going to have even a little bit more involved. Again, we have the binomial squared. However, we have the 3 in front and the -1. So let's compare this to a problem like yesterday. Yesterday, you just had to worry about getting the x squared by itself, but it was the same steps. First, getting rid of that -1 by adding 1 on both sides, you'd get 3x squared equals 135. Then what would we do? Divide both sides by 3. To isolate the square term, in that case it was just x squared, and we'd get 45. Then take the square root of both sides, remembering that when you take the square root, you need to put the plus minus in front of the square root of 45. And lastly, we're going to simplify the radical. Plus or minus, the square root of 45 is 9 times 5. This was a homework problem from yesterday, a worksheet problem. So 3 square root of 5. So notice how this answer looks different than the 3 answers we had above. This answer just has a single term, and it's irrational. The equations on top had two-term answers. The first term is the rational term, the integer is the rational term, and then we have an irrational term. Rational, irrational, rational, irrational. Yesterday, when we have just x squared by itself, it's just the irrational term. So now let's relate this to number 4. Again, I'm going to add 1 to both sides first, but we still have that 3 in front of the binomial. So just like we did on the side, I'm going to divide both sides by 3 again, and now I have the squared part by itself, except it's that binomial instead of the single term. Take the square root of both sides, x minus 5 squared. When we take the square root, we just get the binomial x minus 5. Remember the positive negative in front of the square root of 45. Add 5 to both sides. So now we have that rational part in front of the irrational part. And lastly, we'd have to simplify that square root. However, we already have that done over here for us, so I'm just going to copy the 3 radical 5. Okay, so it follows the same idea, except just after getting the square root, you'd have to do an extra step to get the binomial by itself. Now there's one other case that could occur, and that's when we have one like number 5. Notice what happens when I take the square root of both sides here. Notice the binomial squared was by itself, so we didn't have to isolate. On the left-hand side, again, the binomial will be by itself, x plus 6. But what do you realize when we say positive negative square root of 81? You notice anything about the square root of 81? Square root of 81 is just rational 9. So this is our first time having a rational answer. And that could happen. When I minus 6 from both sides, again, I'm going to put it in front of the plus minus, negative 6 plus or minus 9. However, here, both before the plus minus and after are both rational. So I would not leave it like that at all. I would break this up into negative 6 plus 9 or negative 6 minus 9. Negative 6 plus 9 is 3. Negative 6 minus 9 is negative 15. Negative 15. We have 2 rational solutions, unlike all the other examples that were irrational. That means that this equation was factorable. Remember the last topic from just last week? Factoring quadratics to solve? If your equation has rational roots, rational solutions, that means we could have used the old method. Do you have to? No. Today we're actually doing the new method. But do you guys remember what we'd have to do here? You'd have to get the equation in standard form before we could factor to solve. So I'm squaring out the binomial x plus 6 times x plus 6, x squared plus 12x plus 36. Bring that over here. Plus 12x plus 36 equals 81. Still not in standard form to be factored until I minus 81 on both sides. I get x squared plus 12x minus 45 equals 0. So once we had a standard form quadratic equation, we would factor. We have a trinomial with the leading coefficient of 1, so I would use add multiply here. Set up my factors, x times x for x squared. Factors of 45 is 1 times 45, 3 times 15, 5 times 9. It has to multiply to a negative 45, so one of the numbers has to be negative. It has to add to a positive 12, so the bigger number had to be positive. So I'll make the smaller numbers negative, and negative 3 and positive 15 add to 12. So I'm doing this quickly, not because it's the 4th time I'm doing it, but because this is review from last topic. Set each factor equal to 0, you'd get your 2 solutions, 3 and negative 15. Notice they are the same solutions we got above, except this time by factoring. So the only time you would have the option to factor is if the solutions are rational, which was this last case. All the other answers today had irrational solutions.